Welcome back. In this session on Business Research Lab, we'll be doing solution to the 13th, you can say, exercise, question 2 and question 3. I suppose you have already, you can say, seen and done on your own. So let's look at the way and how the answers can be, you can say, for question number 2 and question number 3. This exercise 13 is all about simple linear regression. So in that case, we all know we have got two variables. Both the variables are in scale form or continuous form. The independent variable is known as the predictor variable, which is predicting the values of the criterion or the dependent variable. And let's read the question two first. So here we have an employee for a school district who wants to know whether a seventh grade math skill entrance exam was predictive of performance as measured by the final grade in the seventh grade mathematics. So the entrance exam scored and the final course grade in the seventh grade mathematics for 30 students were obtained. The possible range of scores on the entrance exam are from 20 to 100, and the final grade in mathematics is from 0 to 100. So higher scores indicate better performance on both measures. The data are in the file 13.2 and the variables are named math exam and grade. So we'll be opening that file to conduct the analysis, and we have to, you can say, state null and altered hypothesis, state the research question, is the predictor significant at alpha is equal to 0.05. We have to find out the effect size and see whether it is small, medium, or large. And finally, you can say we have to write down the result. So this is the question about the students who just when before joining the seventh grade are being tested with, you can say, the math skill entrance exam. So they are qualifying that exam, and maybe you can say, or they are simply, you can say, participating in that exam. Simultaneously, we are also, you can say, looking at, you can say, the final scores or the final grades the students have got in their exams, the final course exam for seventh standard. And then we are seeing that, okay, fine, the students who have obtained um, some marks, maybe lower high in their, you can say, skills exam, is that going to, you can say, have a prediction on the dependent variable, that is the marks obtained by student or grades obtained by student in the final exam. So that is the case. So we are just moving to the new share. So the SPSS file is in front of you. So I'm sharing the file. This is what the file is. So we have got two variables, math exam and grade, and they are both in scale form. Math exam is basically the skill and it is independent variable. Grade is dependent variable. The values are given to us, and we have a data of about 30 students as the question says. So that's the data. So moving back to variable view and conducting the analysis here. Before we conduct the analysis, two things have to be seen, that we have to find out, sorry, we have to answer on the A part of the question, that is stating the null and the alternate hypothesis. If you look at this question, the null hypothesis will be that uh, maths exam is unable to predict the grades of the student, which means beta is equal to 0. And the null hypothesis, that's the null hypothesis, and the alternate hypothesis will be math exam is able to predict the grade of the student for the seventh standard, and beta is not equal to 0. So that is your hypothesis A part. Coming to B part, we have to write down the research question. The research question here is simple. Do math exam skill predict the grade obtained by student in the seventh standard final examination? So that is your research question. Now, talking about, you can say, finding out the predictor being significant or not, or maybe you can say talking about um, your effect size And finally, the conclusion that we are drawing will be dependent on the analysis which we are doing. So the steps for one way, steps for simple linear regression includes analyze, regression, linear, and this is the box we are getting. So this is the reset I'm doing because I just, you can say, done the analysis a while ago. So here we have, you can say, the math exam, which is independent variable. The grade is basically, you can say, dependent variable. And I simply will click on OK. And maybe you can say I need to share the output file with you all to look at the output file. So this is the output file here we have got. So math exam happens to be the independent variable. Dependent variable is the grade, and all variables have been entered. Here, if you look at the value of R, it is 0.726, and R square happens to be 0.527. If you look at the ANOVA, here you can see F value is coming to 31 something, and significance is 0.000. It is highly significant. The same value we are going to get for the t-test also, where the value is for math exam and maybe you can say, and then taking it in relation to the the final, you can say, the the final, you can say, the grade that the student has got. The answer is, you can say, t value is 5.589 and significance happens to be 0.000. One thing I've already told you, when it comes to linear regression, the significance value, be it ANOVA, be it t-test which we are conducting, will remain the same. That's there. So look at the question, C part of the question now. The C part of the question was saying that, okay, fine, is Pareto significant? So the answer is, the Pareto is significant at T within brackets DF is equal to 30 minus 2, that is 28, is equal to 5.589 with P less than 0.5. So that is how you can see we are answering the C part. Coming to D part, and D part, we have to talk about the effect size. We know R square is our effect size. R square happens to be 0.527. So since R square happens to be 0.527, the effect size is large. Since we know that if R square is equal to 0.01, effect size is small. If it is equal to 0.09, effect size is medium, and if R square is equal to 0.24, effect size is supposed to be large. And since you can say our R square value happens to be 0.527, we know that effect size is quite large. Coming to the last E part of the question, where we have to answer on, um, just we have to write down the complete answer for the question. So we say a simple linear regression was performed for operator variable, math exam, and criterion variable, grade obtained by student in 7th standard. The operator variable has is able to you can say predict the value of the categorical variable at t within brackets 28 is equal to 0.559, comma, small p is less than 0.5, comma, r square is equal to 0.527. One thing we should always know, that when I'm talking of r square being 0.527, it actually means that the the maths skill exam which the students give initially is able to, you can say, has an influence of 52.7% on the final exam grade the students are obtaining in 7th standard. So that was the question. Question 2 we were doing, and now we'll move to another question. We'll be talking about question 3. So now we are here with the question 3 of your exercise 13, which is on simple linear regression. So the question is, an industrial psychologist wanted to investigate whether the agreeableness, that is being likable, friendly, and getting along with others, was predictive of success at work. 25 employees were selected and were administered a scale measuring agreeableness. The scale ranged from 7 to 35, with higher scores indicating greater agreeableness. Following the administration of the scale, the supervisor's level of satisfaction with the employee was obtained. Satisfaction scores ranged from 0 to 10, with the higher scores indicating greater satisfaction. The data are in the file that is enclosed and will be, you can say, working on that file. We have to just perform the SPSS analysis, and before that we have to find out the null and alternate hypothesis. We have to, you can say, state the research question, find that whether predictor is significant or not at alpha is equal to 0.05, talk about the effect size as small, medium, or large, talk about the regression equation for the data, and write the final result of the study. So that is something what we have to do in this question here. So if you look at the question here, so if you look at the question, we find that the industrial psychologist wanted to investigate whether agreeableness, being likable, friendly, and getting along with others, was predictive of success at work. So 25 employees we've got, and they were administered a scale which is talking about all you can say variables related to agreeableness. So we have, you can say, the scale ranging from 7 to 35 as the answers coming up, and the highest score the student the employee was having is meaning that they have got a greater agreeableness. And after that, you can say we went for something called the supervisor's level of satisfaction. So how satisfied the supervisor is with that particular employee, and that is being rated by the supervisor for these 25 employees from 0 to 10 based on their performances and how satisfied they are with their employees, those 25 employees. So that's there. Now, studying the null and the alternate hypothesis, we know it's that for null hypothesis, we have the the regression coefficient, which is denoted by symbol beta. So for null hypothesis, beta is equal to 0. For alternate hypothesis, beta is not equal to 0. So this is what null and alternate hypothesis basically are. And for null hypothesis, the actual statement which beta is equal to 0 will mean is that agreeableness is not the predictor for the success of the employee. And the alternate hypothesis says that agreeableness is the predictor for success at work. So that is what null and alternate hypothesis basically are. Research question, if we are talking about, is does agreeableness or is agreeableness able to predict the success at work for an employee? Now, coming to the analysis part, we have to move to the you can say SPSS file. So I'm opening the SPSS file. Here we open. I'm sharing the file. So this is what the file basically is here. And if you go to the file, will be, you can say, just moving to the variable view here. So this is what the variable view is. Agreeableness is one variable. The second variable is satisfaction. And then we are now, you can say, looking at data also. We have got data of, let's see, we have got 25 employees, you can say data. So coming to the analysis part. So first thing we go for, you can say, analyze, and then we go for something called regression. We are going for linear regression. Here we go. Agreeableness is basically, you can say, the independent variable. Satisfaction of that supervisor on how the employee is in terms of agreeableness is dependent variable. We click on OK, and I'm sharing with you the output file. So this is what the output file is. I've shared with you, and here we have got the answers. So agreeableness is the independent variable or the predictor variable. Dependent variable is satisfaction, which is also known as criterion variable. And if you look at the model summary here, The value of r happens to be 0.343 and r square happens to be 0.118. So that's there. As far as the value of ANOVA is concerned, at f value of 3.073, significance is 0.093. And if you look at the t value also, t value is 1.753 with a significance of 0.093. I told you earlier also that the value of t, significance of t and significance of ANOVA will always be same. So it is 0.093. Now coming to C part of the question, when we are to talk about the analysis, you can say, is predictor able to, a predictor variable, that is independent variable, able to predict the criterion or the dependent variable? The answer is at t value of 1.753 and significance of p is equal to 0.093. We are not able to predict the criterion variable, or we can say the predictor variable is unable to predict the criterion variable, or agreeableness is unable to predict the value of satisfaction of an employee by the supervisor. So that's the case here, and this is at alpha is equal to 0.093. Had the value been 0.05 or less than that, we would have accepted the alternate hypothesis. Here we are accepting the null hypothesis. Coming to the value of effect size. Now r square, if you look at r square value is 0.118. This means that r square is 0.118, or you can call it as 11.8%. Now we look at this particular, you can say, effect size as medium, as we know that if the effect size is, or r square is equal to 0.01, it is small, 0.09 is medium, and since our value 0.118 is just near to 0.09, we'll call it the effect size as medium. Had it been 0.24 or more than that, we would have called it large. In this case, the effect size is medium. Now coming to the last part, that is how to write the answer. The answer is uh, a simple linear regression was conducted for the predictor variable being agreeableness and the criterion variable being the satisfaction of employee by the supervisor. Agreeableness as a predictor variable is unable to predict the value of um, satisfaction of an employee by the supervisor at t within brackets 23, that is 25 minus 2. So t within brackets tf is 23 bracket close is equal to 1.753. P small p is greater than 0.05 and comma r square is equal to 0.118. I suppose we have been able to answer the question, and that's the actual thing. So that's you can say solution to question 2 and 3 of simple linear regression. Hopefully you can say this particular, you can say, session or this particular video has been able to help you out in understanding simple linear regression. So I would just request you to go through the notes of simple linear regression, that is chapter 13. Look at the, you can say, the video on example and the exercise 1 which have been mailed to you previously, and now this solution of exercise 2 and 3 will be helping you to learn simple linear regression in a better way. So thank you for the day. I hope you enjoyed the video.